So guys, as I was mentioning that dispersion, so basically when we have a white light, it is sign to the prism, then because white light is composed of various wavelengths, so when it comes out, it bends and it displays these colors. Okay, so this process here, bending of light here due to different wavelength, is called dispersion. Okay, so it, and then also note that this is a white light, right? So the violet color is always bent furthest, red one is bent least. Okay, so this spectrum goes like V, I, B, G, Y, O, R. So violet, blue, indigo, violet, indigo, blue, green, yellow, orange, and then red color. So as I mentioned here, so that is in prism. In nature it happens that we see this rainbow, and then rainbow happens because of the same dispersion phenomena that happens inside the water molecule when the sunlight actually strikes, it penetrates the water molecule, and then the dispersion takes place. So here is a bigger water molecule, picture of water molecule here. These lights are, if you see here, the angle is it is bent at 42 degrees. So by the time it comes out here, it comes out this rainbow color here. See the red color here, also red color is bent least and the violet bends most. Okay, so that is about the dispersion. So let's look at this one example here. So a ray of light enters a right triangular prism. I don't know what happened to my marker, both of these groups. Let's see. So a ray of light enters a right triangular prism. It's a right triangular prism, right? Parallel to the base of the prism. So parallel to the base of the prism. Let me see the diagram. Okay. So it's gonna go parallel to the base of the prism, right? So it's gonna enter like this. If it goes at 90 degrees, it's not gonna bend inside the prism itself, right? It's perpendicular, so it has to go straight. But once it reaches there, it's gonna bend, right? So we can draw a normal here. Normal. Okay. Parallel to the base of the ray. What is the direction of the ray as it exceeds the prism? So we are asked what would be the light would, something like this. This light should come out, but then it is going to come out as what, like this, right? So maybe different color of light there, basically, right? Calculate the result for blue light. Blue light in, let us call NB equal to, for blue light NB equal to NB. Let's just call N for blue. So for blue, N equal to 1.48. For red light, N equal to 1.45. Okay. Assume the upper angle is 30 degrees. So assume this upper angle, meaning this angle of incidence, this is theta, is 30 degree. Okay, theta equal to 30 degree. And we are supposed to find at what angle does this, let's say this is, let's say blue, and then this is like red, they bend basically. That's the thing we are supposed to find. So this is also, you see, it is also like, you know, combination, right? Dispersion is really part of refraction, right? It is also happening there too. But then because of, you know, because different color have different wavelengths, so they refract at a different angle, right? So now what do we want to do is, so what do we know? We know, oh, before this one we should have this, so what is the index of refraction in both of these light? It's coming to the air, right? So that should be 1, okay? So we know, right? We know that in I sine theta, I equal to in R sine theta, right? This is from Snell's law. So Snell's law for refraction, right? So now our incident angle is going to be this 30 degree, right? Okay? And then when it's coming out, it's coming to the air. So that's what we are going to look at. So now let's look at, so for blue color, for blue, what can we see here? So let's let's just generalize this before we do it for blue. So we are supposed to find what is theta r equal to what for blue and what is for red light. Okay, so let's just rewrite this equation 1. If we rewrite this, then we can, what we can do is this, right? We can write Ni sine theta I divide by Nr equal to sine theta r. Okay, I'm just rewriting this equation here. Now I can just take the theta r on the side, right? So theta r equal to sine inverse Ni sine theta I divided by Nr. Okay, so now we have all the information given to us. So just substitute sine inverse of Ni. What is the Ni? So Ni is the refractive index for, let's say, for blue light, right? So it is incident, right? For the blue light we have Ni is what, 1.48, okay? 1.48, and then we have a sine 30 degree divided by Nr, it's reflected into air, so we have like 1. So basically we should get some value here. So this is for blue, okay, this value. So please calculate and see what you get. So you get 0.83 degree, okay, per blue light. Now if you do the same thing for red, write this up here. For red color, you can again use this equation. Let's call this equation 2, just to name it so you can refer it back. Same equation, you just substitute the value for blue and then for red also, okay? So for red light we have theta r, meaning refracted angle, okay? When I say theta r here, not like red or anything like that. Sine inverse of Ni. What is the index of refraction for red color? We had 1.45, right? 45 sine 30 degrees divided by 1, because Nr is again same, right? It is reflected into air. So this is, what do you get here? Please calculate. So this is 0.81 degree. Okay, so it's not a huge difference, but still it's a small difference, right? 0.81 degree, 0.83 degree. So there is 0.02 degree of a dispersed spectrum here. Really, the width would be very tiny. Okay, so these are the angle. So the direction would be what? What would be the direction? So when we are talking about the direction, we are really talking about the angle. So blue color would be, it's going this way, right? Blue. And then the red color would still be outside. It's just a little bit up. Okay? Alright guys, so with this we are done with this chapter. There is a little bit of application of this application of property of light that I will talk on next lecture about optical fiber. But then today let's do the review for exam 2, okay? So let's do some of the problems, practice problem. I'm going to write this problem here on the board. So chapter 15 to chapter 18, okay, for exam 2. Just look at one example here. 41 centimeter length of wire has a mass of 6 grams. It is stretched between two fixed support and is under tension of 160 Newton. What is the fundamental frequency of this wire? Okay guys, so go ahead and try this problem out and then see how far you get, and then we'll work it together, okay? We'll look at the solution together in a few minutes. So. Okay guys, so I have to erase this, okay? I need a space, so I hope you guys have this information. So let's look at this. So the first step is here, just write down the given information, right? Here a length of 41 centimeter length, L is 41 centimeter. We should convert this into meter, so let's make 0.41 meter, and it has a mass of 6 gram. M is 6 gram. Let's convert this into kilograms, so this becomes 6 into 10 to the power minus 3 kilogram. Okay. It is stressed between two fixed support, so support, okay. It has a fixed between two support and it's under a tension T. We are also given tension T, that's 160 Newton. What is the fundamental frequency of this wire? F equal to what? Now do you guys remember? So we know that we looked at the example, right, several examples, so there will be standing wave here, right, on this string. So now this wave here, if you look at the first fundamental frequency, meaning we are talking about, this length would form a wave, something like this, right? So the wave would be, oops, that's the pig's end. I was trying to make it like this, and then this corresponds to our fundamental frequency m equal to 1. Remember, m corresponds to the number of antinode, right? So that would be what we have. So now, what we know is we know what? We know lambda, the wavelength of the wave in this wave, standing wave is given as what? Lambda equal to 2L by m, right? So let us write this as an equation. I mean, we can actually 2L by m. So we are talking about the for fundamental frequency, right? So let's just write this one here for equation 1. And then I'm going to erase this diagram here, okay?